This is question 4 from the final exam, and it's the op-amp question. So this is a different kind of question than what has been traditionally asked in the course, and it's a little bit of a design question, and it demonstrates a digital to analog converter circuit. So we are supposed to find the resistance values here, R1 to R4. And now we have 4 inputs. So we have a V1, V2, V3, and a V4. Those are all inputs. And we're given a table on the right which lists the combinations of input voltages and the output voltage that they produce out here. Okay. So now the question asks part A, find the resistors R1, R2, R3, and R4, and it gives a hint. Okay. Well, first it explains how to read the table. Then it gives us a hint to separately analyze the cases where Vout is -1, Vout is -2, Vout is -4, and Vout is -8. So let's just highlight those in the table beside us. Okay, so we have, first one it's suggesting when the output is -1. Second one it's suggesting when the output is -2. Third one when the output is -4. And the fourth one when the output is -8. So now there's something interesting happening when we are looking at these combinations. So let's look at the first one that's highlighted. We notice that only V4 is 1 and all the rest are 0. So what would that mean? If we now analyze the circuit, we see that it's in some inverting amplifier configuration. We may recognize that it's a summing amplifier, but at least it's an inverting amplifier in some way. We have negative feedback, which means that we have a virtual short circuit at the inputs, so Vn and Vp are at the same voltage. So then we know that this is grounded, so this is at 0 volts, and therefore this is at 0 volts. Okay, we know that. So now, knowing that, we can see that when these inputs, V1, V2, and V3, that's these ones, when they're 0 volts, and if this is 0 volts, then no current is flowing through these resistors. Okay? So the only current that flows is the current that flows this way, okay, through the R4 resistor, and we know that no current flows into the op-amp input, and the current flows out this way, the same current. Okay, so that simplifies our analysis. So now let's see for the second row that's suggested. So we see that only V3 is active and all the other ones are 0. Okay, so current's only flowing because of V3, so that's going to be flowing through R3. Let's look at the third suggested input to look at. Okay, only V2 is active, and the last one, following the same pattern, V1 is active. Okay, so that's why we have this hint. You can solve this in several different ways, so this is probably going to be the easiest way, is if you follow the hint that's given. Okay, and we'll deal with part B later, so let's start actually solving part A. So let's do the first suggested solution. So only one is active. Okay, V4 is the only one that's active, so this is equal to 1 volt, and Vout, so that's Vout out here, and that is equal to -1 volt. Okay, we know that no current is flowing through R3, R2, and R1 because their value is 0. So since we have 0 volts here, and if we have 0 volts here, no current's going to flow. Okay, so then these are out of the circuit. So the only thing we have to worry about is the current that's flowing through here and then through there. So let us represent the circuit more simply the way we have it drawn on the right. Okay, so we've included all of the relevant information. V4 is equal to 1 volt and V out is equal to minus 1 volt. Okay, so then let's perform nodal analysis and let's define a node A, which is going to be over here. And then doing the nodal equations, when we're going out to the left, we are going to get VA minus 1 volt divided by R4. We don't know what R4 is. When we're going up, we're going to have VA minus V out divided by 60 ohms. And then going to the right, we have IN. Okay, so then the next step is to recognize that VA is 0 because of the virtual short circuit, because of the negative feedback. IN, we know, is 0 amps because no current flows into the input terminal of an op-amp, and we were given that in this case V out was minus 1 volt. Okay, so then VA goes to 0, VA goes to 0, VA goes to 0, IN goes to 0, and V out goes to minus 1. Okay, and then we can simplify on the next line where we have minus 1 over R4 plus 1 over 60 being equal to 0, and then solving for R4 we get 60 ohms. Okay, so that's the first resistor that we solved for, so we've solved for this one. So now let's solve for the remaining ones. So we repeat the exact same analysis for R3, except now we're using the next row in the table, and we notice now the difference is the output voltage is minus 2. So then for the output we denote it as minus 2. We do the same nodal analysis knowing that VA is 0 volts because of the virtual short circuit, and then no current flows to the input of the op-amp, and V out in this case is minus 2 volts. And then we get a simplified expression here, minus 1 over R3 plus 2 over 60 being equal to 0. And then when we solve for R3, we get R3 being equal to 30 ohms. So now let us consider a different way of doing solving this for the next resistor. So right now we've solved for R3. We already know R4, so we're going to next go to R2. So we're going to solve for R2 in a different way, and what we're going to do is we're going to recognize, hey, this is an inverting amplifier, okay, and we know the general form of it looks like this, similar to what we drew for the previous two solutions. And we know that the op-amp equation is this: V out is equal to minus RF over RI divided by V in. Okay, so for this situation, we know V out is minus 4 volts, RF is 60, V in is 1 volt. And then if we apply that to our op-amp equation, we plug in those values into here, and then we get minus 4 being equal to minus 60 over Ri times 1. Very similar form as the previous two, except we're approaching it from a different direction. And then we solve to get Ri. Well, in fact, Ri is 15 ohms, but we have to translate it to R2. So this is actually R2. Okay? So then, let's solve for R1 using the same method. So in this case, our output voltage is -8. We've got V1 active. We're solving for R1, and we just plug in to the op-amp equation, and we get R1 being equal to 7.5 ohms. Okay, so now we've solved for all of those resistors. We've solved for R1 to R4, and now we're ready to move on to part B. So let's see what part B was all about. So we're supposed to design a second op-amp circuit that connects to Vout. So Vout is here. Okay, it's going to connect to Vout, and it's going to produce an output voltage VC such that VC is equal to minus Vout. Okay, so it looks like we're going to invert Vout. So this signal here, Vout, we're going to invert it. Okay, so that's what that means. We're just going to make it negative. Okay, and then the last piece of information is we're supposed to use resistor values of not less than 500 ohms. So there's a little typo here. So not less than 500 ohms. Okay, so we're not considering this table anymore. This isn't part of part B. So we have to design a second op-amp circuit that's going to take this signal, and there's going to be some op-amp here creating some VC. So now we have to think what is going to create this minus. Okay, so what comes to my mind is an inverting amplifier. And in fact, this question has been a little bit generous in that what this is basically an inverting amplifier. So it's basically the same thing. So we're going to use an inverting amplifier, and we're just going to connect it like this. So this blue line here is just showing the connection going as an input to this second op-amp circuit. So this Vout is coming in as an input to the second op-amp circuit, and this VC is the output of the second circuit. And this VC is going to be the negative of the input Vout. So don't get confused with what's an input and what's an output. Okay. So then we know this op-amp configuration. It's an inverting amplifier, and we know that the op-amp equation that governs it is in this form. Okay, the output for us is VC is equal to minus RF over RI times Vout, and Vout for us is actually the input to our op-amp circuit. Now we want VC is equal to minus Vout. Okay, so if we look at this equation, we see, okay, what do we have to do to get minus Vout? Okay, so we got the minus sign here. That's great. And so what do we do with the resistors? Well, you know, what's the coefficient in there? It's 1, right? So we want RF over RI to be equal to 1. So that means that RF and RI have to be equal to each other. Okay? So that's both resistors are equal, but what value do we give it? So we were limited to using resistor values of not less than 500 ohms. So we can pick any value that's 500 ohms or greater. Okay, so we can just pick 500 ohms and say that that's for both resistors, for RF and RI, and then we're done. Okay, so we can just put something like, hey, 500 ohms, 500 ohms, and then we're done.